Hi everybody, welcome back. So today is going to be part 2 of my designing a custom watch stand. At least this is the holder part of the stand. And we're going to design it in Fusion 360 and we are going to print it of course on the Ender 3 when we're done. So a couple things. In my last video I mixed up post width and post height when I put those parameters in. The dimension is the same for both of them, so it didn't really make any difference as far as what it looked like is concerned, but I have since switched them so it's correct. I also got a spring down at the local Ace Hardware. It is not exactly the spring I would have liked to have had. The length is perfect, but the diameter, outside diameter, is only about 8 millimeters, 8.5 millimeters, so a little on the narrow side, which means it's going to want to bow from side to side. So I may either have to find something that's a little bit bigger in diameter, or I may have to make a two-piece sleeve to keep it trapped. And that wouldn't be a big deal. But anyway, let's get started on this. The first thing I did, and unfortunately I've already done it and I'm not going to show it to you, but I converted my body into a component. So what I did was I came up over here where it said bodies, and I right-clicked and I selected convert body to component. And that's what we're looking at now. Our part here is now component 1:1. So now what I want to do, excuse me, now what I want to do is I want to make a new component. So I'm going to come up to my top heading. I'm going to click new component. And this one goes out, meaning I'm not working on it anymore. And I'm going to create a sketch. And I'm going to create it on this. And I'm just going to make it out over here someplace. And of course I'm going to start with a circle like I did for the other one, and my dimension is going to be my parameter circle OD. Enter. And then I'm going to create an offset. I'm going to offset the circle, and I am going to offset it by the parameter called offset. Okay, now I only want this right half of this circle. So I'm going to draw a line. I'm going to make sure I'm locked on my center, or hooked on my center anyway, not locked on it. And now I am going to extrude this side of it. And we are extruding it up, called the parameter called part thickness. And there it goes, and we're going to say OK. And now we need to extend these sides out. And so we are going to hit E to extrude. Click there, and they're coming out the parameter leg length. And okay. Come on. Okay, there we go. Couldn't hit it. So the difference now is when the differences are going to start to come in. So the first difference is going to be that these cuts that thin this leg out, instead of being on the inside of it, they're going to be on the outside. So let's do that. So I am going to sketch here. And let's tip it so I can see it, so the other ghosted component isn't in the way. And R for rectangle, and we're going to go there. We're going to come down to there. We want to be slide cut depth here, and we want to be the full width, which is 34, so the other one is fine. So we're going to hit enter, E to extrude, click it, and we're going to come back. And I have a dimension in for this, but on the other one I just came back till I hit this line. And not going to let me do it on this side. Not going to let me do it on this side, is it? Goes from 25 to 30, and the correct amount is 26. Okay, I'll just type it in. There we go. Okay, now let's make our slot. So we're going to create another sketch on this surface, and this is of course going to be another rectangle, and we're going to go there and there. And our width of this slot is going to be slot width. And we're going to hit tab. And our slot length is going to be slot length. Oops, slot length is too long, isn't it? I don't want my slot to go all the way through. So let's go into modify and change parameters. And let's find slot length. It's 26. My tab is 4 millimeters. It's going to fit in. So let's make the closed end of that 4 millimeters too. So let's call it 22. And OK. And now we have to center this. and my slot over my tab over here was I made it 12 millimeters. I made my slot 12.4. So my center dimension over here was 11, so that means this one's going to be 10.8, doesn't it? So D for dimension, going to go there, going to go there, going to be 10.8. And now we're going to extrude this through. And I don't really need to do both sides of this since this is symmetrical from side to side. I should be able just to drag this cut all the way through. And I think what I'll do is say distance to object and then just pick this side, and that should cut me all the way through. Oh, I forgot to make my slot on. I forgot to make my thinning cut on the other side. No problem. We'll do that now. So we're going to sketch on this surface now. And we are going to make another rectangle. And we're going to go here and here. And our width is going to be slot width. And we are going to be, okay, that's not right. Oh, what did I do? I picked slot instead of slide. I've been doing that a lot. Slide cut width is where we're going to be. And that's not right either. Okay. Oh, I'm on the wrong one, that's why. No, I'm not. Slot width. No, slide, Chuck, not slot. Man, these parameters make me crazy sometimes. Slide cut depth. There we go. That wasn't that hard, was it? Okay. E to extrude. And we're going to extrude the outside of this part, this one. And we're going to extrude it back 26 millimeters. And for some reason, it doesn't want to go 26 on me like the other one did, 26. And okay. Alrighty. Now I have the two parts that should fit together. So let's put the spring post in. And to put the spring post in, I need to do what I did on the other time. I need to make an offset plane. So create an offset plane. I want to use this plane. I want to drag it over. And let's move like this. I want to drag it over until it is right at the edge of that, and it is right there. Sometimes I have to type an extra millimeter in or less, more or less, to get it, but it did it perfect that time. Okay, and now I am going to create a sketch on this offset plane. And let's tip it again. I don't like working through the ghosted one, kind of drives me nuts. I mean, I could hide it completely, but you know, I could come over here to my light bulb and click my light bulb and hide it completely, but sometimes I like it there and sometimes I don't. Anyway, we're now going to create a circle on this offset plane, and this circle is going to be post diameter. I accidentally picked post height in the other one, as I mentioned earlier, but height and diameter are both 10 millimeters. But if you ever wanted to go back and change one and you got them mixed up, then you'd notice it pretty quickly, I would hope. But then again, you might be me and you wouldn't. So let's locate this now. So let's go D for dimension, and we're going to click our circle, and we're going to go to this outside line, and this is going to be circle OD divided by 2. And let's dimension it now up to here. And this is going to be part thickness divided by 2. And the reason we do this with parameters is because if I came back and changed my circle OD or my part thickness, this would, using part thickness divided by 2, this would still be located in the center. Now, I don't plan on having to do that with this, but you know what? You never plan on stuff and then you wind up doing it anyway. So let's hit E for extrude. Let's bring this out. Whoops. Let's bring this out. Come on. And this is going to be a negative, isn't it? So this is going to be, whoops. This is going to be, where did my dimension go? Meters. Sure, meters. This is going to be post height, and I have to put a minus in front of it for some reason because it's on the mirror side of it. I messed that up. Okay, let's get it back up. Come down here, click Edit Feature. I know what I did. It's set to cut. I need it set to join. And okay. And now we're going to create a sketch on this surface. And it's going to be another center diameter circle. And this one is going to be post diameter small. And enter. And E to extrude. And this is going to be post height small, and for some reason it's not requiring a negative there, and join is correct and okay. And let's zoom back out. So there we have it. That's pretty much the extent of this piece. But while we're here and we're working on it, and we haven't really been that long, a little shy of 11 minutes, let's make a joint. Let's put it together as a workable functional part. So we're going to construct we're going to assemble a joint, or J on the keyboard. This one should be really simple. Other than some of the ones I've done, I should be able simply to pick this flat surface here, and then I should be able to pick the mating flat surface over here, and I should tell it to put it together, and there it went. So there is our joint, but we don't want a rigid joint. This joint is going to be a slider. And we're going to say OK. And now we're going to come up to our joint over here under joints. You see this little button here at the end? We can edit joint limits. So we're going to have a minimum limit of 0. And we're going to have a maximum limit of, what did we say that's going to move? 22 millimeters? Let's try 22. 22. Is that right? Or is that too much, isn't it? It's going to be... That's not taking into account the thickness of the tab. So it's actually going to be 4 less. It's going to be 18. That looks right, doesn't it? And okay, so now let's come up to here and let's say animate. Well, where did we go here? I want to animate my joint. Animate joint. There we go. So there you have it. There is the first part, the first completed modular part of this. I don't know what to call it. It's going to be a watch stand, it's going to be a storage box, and it's also going to be the watch holder part for a winder for automatic watches. And right now my only automatic watches are Seiko Kinetics, and I know supposedly they don't work too well in winders. But we're going to try it anyway, and I've always wanted a real automatic watch. And hell, the Invicta Pro Diver isn't very expensive, and it has the Seiko automatic movement in it. Not the kinetic movement, the real automatic movement. And so we might get one of those to try it. And I've got some of the electronics to make the actual winder mechanism with. So this is going to be our first part. My only concern is, will the spring work, or is it going to bow out? And will I have to make a couple of sleeves? And I may have to redesign the post slightly if I have to make a sleeve. But I also may get on the internet and see if I can get a 12 millimeter, 14 millimeter wide spring for it. And that might be wide enough to keep it from bowing. I also don't want to make the spring power so high that it rips, rubber watch straps apart either. So I got to be careful with that too. So there you go. I'm going to get this printed out, and I will get back to you when I do. Hey, thanks for watching. If you enjoyed this video, if you've learned something, if I've helped you in any way, please like and subscribe. Click on notifications. I have some links to GearBest below. If you guys want to buy anything from them, you'd be doing me a favor if you clicked on those links. I appreciate it very much, those of you who have. Talk to you later. Bye for now.